This is again a senior eternal voice. Okay, we will proceed now to our topic. Last topic for physics. Oh my god. Okay. What's this? Wait for a while. Okay. Our topic for today is electric potential energy. Electric potential energy. Okay. Potential energy. Diba? If you try to recall, we have already the hello. I proceed immediately without any side talks, right? So we have also actually this is EPE, right? But sad to say, we have also another EPE, which is the elastic potential energy. Elastic potential energy. If you can still remember the formula, we need to scrutinize this one by one, huh? Okay. It's also okay. We have another gravitational potential energy. Gravitational. So there's a lot of potential energy, right? So our title for this is types of potential energies, right? Okay. So gravitational. Oh my gosh. No ink. Child. Gravitational. Okay. Potential energy. Okay, gravitational potential energy. Okay. Like this. So we're talking about potential energy, then we need to have the basic formula of potential energy. So we have mass times acceleration due to gravity, or shall we say this is the gravitational field strength, okay, times the height. Okay, so don't forget that the height will always be there. Okay? Now if we have a potential energy, the partner of potential energy is the kinetic energy. Right? So kinetic energy is equal to 1/2 times mass times velocity times squared. Okay? Like that. So if we have this potential energy and kinetic energy, by the way, these are only the two fundamental types of energies. Forms of energies, but those are not types. Those are forms. Okay? So for example, of the forms of energies, we have chemical energy, mechanical energy, like that, light energy, acoustic energy, let's say radiation energy, pneumatic energy, radiation energy, like that. And then there's a lot, right? Internal energy, heat energy, what else? There's a lot, right? Exothermic daw, wala naman exothermic. Okay. Basta, so many. Because it is under under the first law of thermodynamics. If you can still remember that. Okay, so this all about energies are being discussed a little bit also in the last part of chemistry textbooks. Usually deals with energies. Because what's being discussed in chemistry textbooks are usually matter and the changes it undergoes. Chemical changes, chemical reactions, something like that, but also impossible, right? We cannot finish all the entire books in, let's say, 3,000 pages in one book. Our teachers will just choose the most important subjects or topics, right? So at the back of the book, it's in there. In chemistry, we also discuss work, internal energy, enthalpy, entropy. Even though these topics guys are energy, what else, enthalpy, and discussed also in the last part of chemistry textbook, but it's coming back again in physics, okay, and introductory, and after that it will come back again in physical chemistry, okay, so phy chem. That is if you're taking up chemical engineering. But if you don't take chemical engineering, it will just stop there in the physics and also in thermodynamics. Sorry for that. Okay? In thermodynamics also. Again, physics, okay, uh, thermodynamics, okay, and then physical chemistry, okay, and a little bit of chemistry in the last part, okay, like that. Okay, why in chemistry a lot? Also, because chemistry also deals with the study of, matter, and we have commonalities with each other with physics because, as we keep on telling you guys every time, physics is a branch of science that deals with the study of matter, right? And energy, and also chemistry is a branch of science that deals with the study of matter again, right? And that changes it undergoes. So the commonalities is the matter. That's why we need to study also the commonalities, which is specifically energy part. Okay? Because the matter also that's linked with energy because most of the matter will behave in motion if they will be charged or put into motion, something like that. Right? Ako yung discussion guys ha. Okay, based on my understanding. Okay? Like that. Okay? It's gonna be like that. That's what I really noticed. Okay? Ganon. So if our question will say that what are the three types of potential energy, your answer will be electric potential energy, elastic potential energy, and gravitational potential energy. Since we are introducing to you the different types of potential energies, and we'll be able also to define each with corresponding formulas and equations. Okay. So it's gonna be like that your study. You're gonna study first the introductory and then part of the topic, and after that you have to understand what it's all about, and then you need to understand what the equations and formulas, and like that you know to how to derive the formulas and equations, and you will also know who are the persons in your study. Do not focus on we will read or like that. The importance on the theory. Okay, based on the confession also because okay, so the fun of loving, too much problem solving, problem solving, problem solving. And then when you ask a single theory, they cannot answer very well. Okay? When you ask them, what is entropy? Something like that. But they know the formula. But they cannot state only the definition. They don't know that the formula is also a definition. Okay? The definition. Not necessarily the one that is reflected in the book. Okay? You get the point? For example, if you know the formula of pressure, pressure is equal to force area. I have to ask you, what is the definition? What is pressure? Okay? Since you are not memorizing the statements in the book, you will never answer, but you know the formula. This is just the definition of the pressure. Convert that into statement. Right? And that's the definition already. Something like that. You get the point. Okay? Wala na akong na-notice. Okay? Sa college. Kusog kayo musog, dito sa IT, grabe kayo. Perfect, perfect, good na. Charot! Charot lang. Lagi, paspas kayo musog. Okay, so, ano na siya, no? Okay, ako rin din yung musog. Charot! Okay, so we have EPE lang po siya guys because electric potential energy na elastic sa EPE message siya. Okay, so that's why the book stated a variable, a letter that is not the same. For example, for elastic potential energy, we put that as a W, and then for electric potential, we put that as a U, right? U ba to siya? Yes, U. Something like that. Okay? For the gravitational also, guys, sometimes the declaration of the nomenclature, the coding, the variable, it looks like, it's misleading sometimes. But you need to stick to the topic where you are at present so that you will not be confused, right? So gravitational potential energy, that is also UG. See? UG subscript only the reference here without subscript. Okay? So for example, what are the three types of potential energy? Your answer will be electric potential energy, elastic potential energy, and gravitational potential energy. And then what is your formula? So since I talked about the kinetic energy, okay, so if we can remember in our basic physics in, high school, I think this is discussed also in high school already. So we will say that, okay, like this, okay, ganun siya. So, kinetic energy plus yung ganon, okay? Always take note this too, okay, because they will go hand in hand together, okay? Especially in the Bernoulli theory equation, the kinetic energy and potential energy are built in that equation. All you have to do is to add density and to add what else? Pressure. So you need to add hydraulic pressure, elevation pressure, something like that for this. But it's gonna be the potential energy, the elevation pressure already. You have to add the pneumatic pressure also. Okay? So this is the basis. Okay? I'm also studying and all that. Okay? In the finals, topics. But during this understood in the past, sometimes to tackle correlation in the past so that this will be also because because it depends on the instructor's also capability and style. Okay? It's gonna be like that. But for on the instructor's also capability and style. Okay? It's gonna be like that. But for me, honestly, if I am, an instructor, professor, I need to correlate everything in one single setting. Okay? Of course, I don't have to say B because too much talking, then my time will be finished also. Okay? It's gonna be like that. Okay, ganon. Okay. So makinomdom na tatong, for example, ang high filter rate. For example, the topic is more on the ideal gas laws. And then, Babin in the examination will touch about geometry. Okay, you get the point. Huh? The question will say, what is the diameter of the pipeline? Something like that. Di ba sobrang layo? Okay, you are only asking to the a little bit far away, but it's really you need also to go this one. You need to extra the majority of your attention. Okay, ganon. It's not also an effective teacher if in your class. Okay, you should not change the culture. Okay, the terrorism instructors in the university, uplifting if we need to say they're happy that nobody gets their question. That tells that you are an effective teacher and instructor. Change the mentality and culture so that you can motivate yourself in future examination. They will remember you. Okay, remember you, your legacy, how you explain very well the topics, and it will flash back into their memory that this is from Sir Sotero's discussion like that. Okay, di ba? Fulfill kayo ka nga i-mention kanila sa ilang. Though it's only an imagination, it's only in their brain cells. Sometimes we talk to our minds only, right? Remember, when we are in college, we talk to our minds only. Not necessarily we need to voice out that one, but we need to talk in our brain cells, especially when we are studying. Okay, you got the point. Oh, something like that. Okay, and it is very, very good to remember our chapters in a positive point of view. Okay. So, electric potential we have U is equals to Q times V. Right? Ganon. So, it's this U, electric potential energy in terms of electric potential and charge. But this formula doesn't involve the distances. Okay? Because most of the times it involves distances in electric charge. Something like that. Okay? Okay, now also another formula that work is equals to negative something like that Q over V. Okay, so the word really is popular, right? You can imagine you can also found work equation in dealing with molecules, dealing with atoms, dealing with the flow of gases, dealing with the flow with liquids, solids, all substances. There's work, even objects, and even human being. Something that, for example, if I have my like this here, actual example here. Naku, planggana. Sure, planggana. What's the English of planggana? Basin? Kaloka. Okay, I will push this there in front. I have work done already by applying my force and it covers a distance. So this is a work applied in object by a human being. But in terms also in microstate, meaning microstate in a elementary particles means microscopic point of view, molecules, ions, atoms, protons, electrons, in which we cannot see in our eyes. Okay, we can also apply work there by moving molecules with a certain velocity and forces as well. Okay, things like that. In here also, in electricity, objects to objects, it's also applicable in electricity or practical electricity topic, right? So it's going to be work is equals to your charge. Okay, charge means it could be a positively charged particle or a negatively charged particle, something like that. And then the V will be your electric potential. Be careful also with your electric potential, guys, because sometimes it will put only electric potential, but this is only the voltage, like that, the EMF, okay, or simply the volt, something. You got the point? So there are so many, the same name, electric potential, voltage, EMF, or volt, something like that. Okay, sometimes potential difference, or potential only. Okay, not necessarily putting electrical, but potential is also electrical potential. Something like that. Voltage, so volt also, EMF, and so on. So you should also figure out the unit. But sometimes unit is not also mentioned. Like that only. What is the potential of blah 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 so and so when it's connected to a voltage cell or a battery, something like that. So, di ba? So at least you know. Okay? Ganon. Okay, that is the formula of the word. Okay. Now we are going to derive an equation that relates to the distances of your charges. Okay? This is not yet, right? Because this is not involving distances or vertical distances, right? Of your moving electrical charges. Okay? How can we do this? Charot. Okay, for example, andyan na naman tayo. Okay? For example, if you have this two metallic plates, okay, shall we say a conductor, right? Andyan na naman tayo, conductor. So what is a conductor? Or what is a conductance? Okay, something like that. Meaning to say the conductance is a process. The conductor is a player or an actor to produce a conductance. The unit is farad, something like that. Okay, a conductor of electricity. Okay, to conduct electricity. So, for example, this is your ganan, so this is your metallic, something like that. Okay, metallic plates. Obviously, that is your conductor, right? Conductor. So we have that as an electrodes. Electrode. Okay, we have electrode that is specifically the anode and the cathode. Okay. At the point. Ganon. Take note, guys, the anode and the cathode. Remember for this, you know this theory already? There's something confusing for this. For example, I will say cut ion. Okay, cut ion. Cut ion is positively charged particles. Okay, will go to the anode. To the anode. An ion particle. It will guys. Okay, so outside. Okay. So, pado dapat kathode ka. Okay, nag-start siya sa CAT. But that is not the situation. I also an anion. So, kung sabihin ito siya sa anode, ano man ang sugod. like that. Okay, I have to put negative here, positive here. So here is the positive. If this is opposite. If there's no opposite, then there will be no attractive electrical charges or forces involved. There will be no electricity because it will repel. Okay? So you need to study more about 06 to 17th century history, all about electrical charges, the law of magnetism, like that, the electrical current in our hair, put in the refrigerator, the electricity is all are under with the study of, Benjamin Franklin. Okay? You should also read his contribution about that. Okay? Okay, going back here. So, wala siya, no? So, di ba? Okay. So, ang theory, guys, yung tinanong na is under direction. Again, the electric field, the forces, and the direction. Because you forces and the electrical field. But most of the times, net forces joule. Okay. Now, if you have the capacity from this, you go there. Oh, this is your electric field. Okay. So by theory, the electric field and the force is having, on the same direction. So your force also will be going there, the capacity in the right. Okay? This is important because when you add in the net force, the sign matters a lot. If you subtract, if you add, so masayok ka. Okay? And then this negative also charge here. So your force has an electric field. Electric field will go there on the material. Okay? And then your force also will go in the material, something like that. Okay? Ganon. So, mo repel, then mo attract. Ganon. So, and then we also understand the repulsive and attractive forces in intermolecular forces. That's also discussed in chemistry. It's partly related here in the law of polarity and in the law of magnetism. Actually, this is electromagnetism. Okay, something like that. Okay, going back. Okay. Okay, I will just make fast this because it's also a long story. If we try to discuss everything, we will reach midnight. Okay, so we need to go, straightforward also with a little bit of chika-chika galore. Okay, ganon. So I have here like this. Okay, so ako na check it to 1. Okay, so this will be your positive conductor, right? Okay, positive conductor. By the way, what is a conductor? Anybody? Okay, the conductor is a device particles in it. Okay, meaning the particles are being charged. That's why it produces an electric charge and electric energy. Meaning to say the current. Okay, then we have also here the negative. Okay, ganon. Okay, like that. So, okay, the battery here, okay. Okay, so you need to determine the electric field. Okay, electric field. So, if this is the arrow, will be downward. Okay, and the force also will be the same, going downward. Take note always the electric field and the force will be yung point in reality. So, your presentation of your distance is vertically. Okay, okay. So put the image na here will emphasize the halfway. Okay. Okay, wait. Saan nawala ang base. So definitely, so that is new. Okay, like that. So that is new goes to okay, like that. The north, east, north, south, and east. Like that. One revolution. In terms of angle of inclination, degrees, a lot of degrees, right? So that's also part of direction. When the question will say, what is the magnitude and direction? The magnitude there is the value in terms of numbers, figures, amount, blah, blah, blah. But your direction there would mean the east, the north, the south, the west, the negative sign, the positive sign, because basically the top is also positive and the downward is also negative, like that. Okay, but if a question asks 360 degrees in the air velocity, computation of air velocity and wind velocity, something like that, and also the, what do you call this one? In the navigation, problem solving, navigation, sa mga boat, ship that deals with nautical miles per hour, like that in the sea or in the ocean, this kind of problems. Okay, because the direction is very important there, especially the pilot. If the pilot go to the direction, then he will not put the direction because the final destination is traveling with a desired velocity, right? Magnitude and direction, something like that. Okay? It's gonna be like that. So meaning they are clever to that. Okay? So the same here also, you need to apply the direction. Okay? Since here the direction is positive and negative only, so you don't have to worry. Okay? Like that. Okay, now, so we have this basic concept. Okay? So magbalik talaga na siya. Almost last 3 months discussion, I would say. What is a work? Can you still answer? Okay, what is a work? Then what is an energy? What is an energy? What is a work? So quality here. Okay? Then you need first to know the statement theory before applying that to the formula. Okay, and then later we'll convert that to formula or equation. So what is a work? Because W is a work. Okay? Like that. Okay. Then work coming from the energy. Okay? What is an energy? In layman's term, only not a technical definition, okay? So, energy is the ability, okay, is the ability and the capacity to do work. Okay? The capacity to do that. So, work is, you need to say the energy, you cannot have an energy if there is no work done. Okay, so there's no evidence that you have energy if you don't have the work done. For example, if I push this one there, if it doesn't move, I don't have the energy. I have only the force, but I don't have the energy. Because the energy evidence is the distance covered when I push this distance. Okay? You always apply force, of course, because all of us will die if there's no force. We are not alive if we don't have force. Okay? Because all our vital organs have forces involved in it. Okay? Under natural situation, okay. Something like that. Okay, if there's no distance covered, there's no work, and energy is the ability to capacity to do work. So basically, we can say work is tantamount to energy, or dependent with each other, or complementary with each other. Okay, so directly proportional with each other. So if you have a very large energy, okay, in doing that certain task or work, if you have a less energy, then obviously you have work is times distance. I will put this force times distance here so that I can derive the formula. Okay, ganon. Okay, magsugod na tag-derive. Okay, nakapalawa. So work is equal to force times distance. And what is your internal, sorry, what is your electric potential energy? This one. U. Okay? Okay, sometimes get confused ko guys because electricity is not my masterpiece, okay? A little bit far away with chemicals, right? Sometimes I confuse with the terms also because you know this U is internal energy in science. Internal energy, not the electric potential. Then since the topic is really electric potential energy, then I have to adjust the U. The U is a symbol of operations. But in here, my word will be mistake. Something like that. So, nahanap ko nga, this is electricity. Ganon. Okay. This is electric potential energy. I'll never erase na talaga. So, tinusipit ko nila. Okay, electric potential energy. So, sama niya siya, negative. O, ganon. So in our drawing here in equation, we have the B and have also the YA. So you try to put into account that the B is your final and your initial will be the A. In usual cases, that would be the case. B final, A initial. in almost everything in science. Okay? B final, A initial, 2 final, 1 initial. Something like that. It's gonna be like that only. Out. Okay. O is final. Ganun. I is initial. 1 is initial. 2 is final. A is initial. B is final. These are these are the variables that kept on repeating from first year college to fifth year college in engineering. In all problems, this will be expressed in this way, especially if you are dealing with final states in a system. Final states in a system usually refers to the initial, the final, the output, the input. So that's what we mean of states. Okay, STAT is final function. Okay, or state function. Diba? State function din sa physical chemistry. Yes, state function ang tawagan niya, guys. Okay? Ganon. So, anak ko siya mong dire, kaya di mo na itong pagbutan dire ari. So, you need to say, okay, U, B, ganon. But you carry the sign first. Negative A. So, UB minus UA. Now, to avoid confusion, again, algebra, math. To avoid confusion, this is the time you need to put bracket because it will confuse in your sign here. The law of the technique of algebra, you need to put the parentheses or the bracket so that it will not confuse the sign during multiplication, during distribution multiplication operation in a linear algebraic expression. Something like that. You get the point? So we need to put bracket like that. Okay, so take note, guys, the technique of algebra, which is the PEMDAS rule. Okay, don't forget this one. This is very important. Start with the parentheses, exponent, multiplication, division, addition, subtraction. Then if you start somewhere along the way, you will not start this analysis, then your answer will be wrong. Especially if there are so many things to do from left to right. Rumbled by multiplication, division, length, and there's so many things there. There's exponent, there's a parenthesis. So, maglibog is in the left. Be careful because in the PEMDAS rule, the parenthesis is number 1. So you will start to the last. You get the point? And engineers are very good to this. Okay? These are already engraved in their brain cells. The PEMDAS rule. Okay? So, mayabo matakay, lain siya answer if you start to the middle first and then the last first. And this normally in our high school and elementary, we are taught by our teachers to start with the right. Okay, in adding and subtracting, but doesn't not hold through every time, especially if it involves linear equation, blah blah blah, so and so. Okay, so it's gonna be UB minus UA. And how the force? Okay, how can I relate the force to this equation? And then you think also another equation in the past that involve Q, because Q is the commonality. So there's no other thing. You have to think that electric field, ako na lang, okay, electric field is equals to electric force over the charge Q. And then mulugwa ang force. Okay. Then compute for the force, substitute that here. Okay, ganon. So, the purpose of correlation is the past. Okay. So the force will be equal to the electric field. Okay. Times the charge Q times the distance. Is more on the design. You integrate and differentiate. For example, if you have the capacity, the flow rate, the pressure, the temperature, the viscosity, the specific gravity, everything to know that but if your job only doesn't require that, it's fine. There. Okay, unless you are designing an equipment, okay, or something like that. So, for example, if you are in a consultancy firm, you are a design engineer, whatever, to talk everything to your clients, then you need to be connected to the customers. And in construction industry, not only horizontal, some is going up, T type of pipeline, you have to put the angle of elevation. Then you use trigonometry. Something like that. To the point, even though there are pipe meters already a trigonometry, a math Okay, you get the point. So something like that. So mga angular declinations. Okay. Now going back to this, what you notice here, if you apply the theory of algebra, take note. So pareho siya guys of commonalities, commonalities in English. Is there another term for commonalities? Common to each other, something like that. So, U. So you will say this also, like in algebra, you will say like this also. Wait ha. Naunin mo siya mga kalangga. Charot. Kaloka. Okay. It's gonna be partner ang negative EQA and the UA. Partner ang negative UB o ang B. So you will say UA is equals to negative electric field okay, B. Ganon. Okay? Now, U and UB is common as U or D. Okay, these are our electric potential. Final definition. Then what potential energy of what? Okay, the potential energy of what? Okay, that's very long. Okay, the potential. We have still another process. Again, we still have. Okay. Now, in this moment, we will be able to summarize all formula electricity. Okay, so that you're expanding, not limiting only to Ohm's law. Okay, you get the point. This Ohm's law is very common to what? So we need to derive another equation, of course. And then this problem solving, and then later on the application. Regarding to their will be the last, we have thesis, equipment. This we like that only the for in the total year of curriculum. Okay? Ano lang siya? Nag-share exposure ang last. Okay? So nalihan ka itong mga field to reap in different industries like that, chuchu, and then the thesis, design, equipment design, something like that. Okay. Now, we have to derive another equation here. But this equation allows, because I don't like this picture, I need the other one. Okay, because very easy to detect. Okay, so now, we will need to solve another equation which relates to the electric potential voltage and the distance only. Okay, we relate to electric field. Okay, something like that. Okay, it's gonna be like okay, this one, right? Again, equation 2. Okay, what is the definition of work? Force times distance. Always remember that forever walang katapusan. Okay, even though we will die already, our future generations will still be using this equation forever in infinity. And will really cover. Right? And then additional value here, me personally, I still don't know if it is still the floating historic area. There are a lot of factors that need to be polished. Again, they need to upgrade. Everybody will have shoes. Okay? So it was also in brains equation electricity and field like that, weak nuclear forces, you don't have to do that. Okay, because that is not already here. Okay, you get the point. So far again. Okay, going back. Okay, so force times distance. Okay, times electric field, walang katapusan. We are having this formula, then we need to maximize the force in our literature. Okay, something like that. Okay, so we need to determine that. Like that. Okay, farad. 1 farad. Nangani, di ba? So 1 farad is equals to the seconds raised to the power 4 times ampere raised to the power 2 over kilogram times square meter. Amazing. There are 4 quantities units of farad. Farad is the basic unit of the capacitance. Okay, like that. So we have now. So what is a capacitance formula? Okay, let's say capital C. Right, ganon. So capital C is equals to the source charge, capital Q. Okay, capital Q. Let's say capital Q because the source. Okay, like that. And then you have the applied voltage, V. So this is also your formula of your capacitance. So it involves gagawin siyang charge o commodities sa electric field. You get the point, anak siya. Okay? You get the point. Now in here, mga palangga kong hitad. Okay, in here. Tadadat. Ganon. Okay. Ganon. So here, you will compute also for the electric potential. Electric potential is equals to U over Q. And this is electric potential energy. What is the unit of energy? Diyan na naman tayo. What is the main unit of energy in standard? Okay, there's a lot, right? Calorie, kilocalorie, British thermal unit, okay, horsepower, watts, so erg. Right? So the standard unit in SI of energy is the joule, not a calorie. Because calorie is for substances, foods, drinks, liquids. Check also the applicability, where to apply. Unless the problems will say calculate and convert, there's no issue to that. Because what you're trying to emphasize is at least you know how to convert. But the applicability is very important also. Alam mo, you will say, what is the calorie driven by a motor pump? So it sounds illogical. But you can do that because there's an equivalent how to convert that. For the purpose only of knowing how to convert calorie, it's expressed either in horsepower or in watts. Okay. So going back here, so we have the electric potential is equals to internal energy over the charge. Again, there's a Q. Oh, common pagyapon siya dari ari. So we need to have joule over coulomb because the unit of the charge is coulomb. So joules per coulomb. Sa ito pa, therefore, I conclude 1 volt is equal to 1 joule per coulomb. Okay, you don't necessarily to memorize, but if you know the formula, then you can know also the equivalence of the conversion factor. Okay? Okay, but normally when I was in college, I memorized both. In case I will forget the memory, then I have to use the unit. Because sometimes also it's also eating my time just to have the formula. I have to remember the unit. So in complicated or complex, then I have to do. But in a very simple, easy to memorize, you don't have to do that, right? You get the point? Something like that. Okay, what else? We have now equation 1, equation 2, equation 3. Okay, and you have also equation first charge over the distance of separation of the charges raised to the power 2. This also involve charges. What else? We have the equation 4. We have still another. We have the current. Capital charges equal to 4%. Okay, and then with the voltage in terms of Q, okay, which is that Q. And if you have the voltage, so U over Q over time, right? Diba? Get the point? So U over Q, and then you can also have this U over Q over time times T. So you will say electric potential over the charge times the time is also a formula of magnetic flux in terms of charge again. Because our purpose only is to match formulas that involve charges. Okay, so 6 na siya. Equation 6. So, for example, in the problem solving, so calculate the magnetic flux of blah 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 so and so. And then the given also is like this. So you can also compute because you maximize already your learning in terms of charges with regards to magnetic flux. Okay, so there's a lot, right? There's still a lot. There's only an example. Okay, so and then you can derive blah 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 so and so, connect that everything there. You can do interpolation, extrapolation, ratio proportion, ganon. Okay, you get the point. So what do you mean by extrapolation, Sotero? Extrapolation is really you have the same quantities and you put that into a ratio. Okay, like that. You get the point? Actually, this is also ratio and proportion, but extrapolation, because that involves already so many quantities. Okay? That's why extrapolation. Extrapolate. And then the interpolation is another thing. You have already the table, the values, and then you have to give the in between values, like that, because it's not mentioned specifically there. Usually a standard temperature and pressure, the ganon. Okay? So that's another thing also. We have also double interpolation. Okay? Double interpolation, simple interpolation, and ganon siya. Okay? You get the point. For example, sa ratio and proportion extrapolation, E1 over E2 is equals to D1 over D2 raised to the power 2. Okay? So, through din meron siya. Sa extrapolation, okay, sa voltage na formula, na E is equals to the voltage electric potential over D. Okay? And then you assume that you have a consistent and a constant electric potential somewhere along the way. If you assume one quantity to be like that, then it's easy for you to extrapolate, and it's easy also to have a ratio and proportion. That's a technique also in math. That's why sometimes you will say, why like this, the other quantities are lost? Because you need to assume constant somewhere along the way in the particular equations, like this, internal energy, blah, 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 electric potential. There are three quantities. Then somewhere along the way, you need to treat that your surface area is equal somewhere along the way, that nothing happens or nothing changes. Then you can assume that is equal in point 1 and point 2. Then you have to equate and you have to do the ratio and proportion. That's why the quantity area has been rejected in your actual derivation. So we like that in engineering. But just go with the basic. Okay, so that mamundo ka o score. Are sa basic concepts. Din sa mga difficult. Okay, ganon. Okay, so we're going to okay, so if I have that, so negative Q times V, ang second purpose is to have another equation with regards to the electric field and electric potential, right? Okay, so force is equals to, again, electric field is equals to electric force over the charge. Okay, cross multiplication. Because I love cross multiplication technique in algebra. Okay, actually there's a lot. Okay. Like that. So how can we do that? It's gonna be electric field times Q, because you are trying to ask for the force. Okay, electric field times Q times distance is equal to negative QV. Okay, commonalities. Actually, you can consider the Q, supposedly. But I don't have to do that because there's another sign here, negative and positive. So I need to apply another technique. This is not cross multiplication. Why? Because there's no denominator. So put that in your brain cells. If there's no denominator, you cannot do the cross multiplication technique in algebra. You need to multiply for a certain quantity so that it will be cancelled somewhere along the way. It should be 1 over Q over D, because you are trying to solve, you are after with the electrical field man. So if you are trying to get the formula and you are after and you are really wanted for that quantity, then you need to multiply something that walang mulubog sa engkilid. You get the point? Or there's no congestion. Okay, I can't explain. So that there will be no complication or other quantities will be there. Solo flight and siya or alone. So I need to multiply this 1 over Q over this so that it will be cancelled the QB here. If you multiply this, electric field, because the Q will be cancelled here if you multiply that with 1A. So negative QB over 1 formula of electric field is here. Nasa ibang formula, electric field. Okay? So, since, for example, guys, if you notice the problem, if there are two mentioning the voltage, so it's gonna be delta change already, in a certain variable that would automatically get a change to something, change to something, change to something. For example, here, if you have two distances mentioned, so this change in distance. Okay? But if it is only one mentioned there, you just put it as D. It doesn't matter whether it is initial or final. Okay? Over usually, meaning variable. Okay? So, there's also not variable, but most of the times, okay, like that. So you put delta V. This is true for all, formula is not only limited to electricity. This delta delta meaning that is it goes really to the from the positive electric potential to a negative electric potential. Okay, just like the, for example, if you're trying to say the heat transfer that is from the higher temperature to the lower temperature as you change of your delta T. In here also, in the change of delta V from the positive electric potential to the negative electric potential, which is also true, right? Because from higher temperature, it means positive, and the lower temperature will be somewhat kind of going to the negative. So it will hold true in all kinds of theory, something like that. Get the point? Or if you try gradients and velocity, okay, from higher velocity of the molecules to the lower velocity of the molecules. Okay? Because we are talking of the molecular energy in fluid flow. Okay, so molecular velocities, something like that. Okay? You get the point? Wala na siyang tansa na naman chupa-chup-chup. Okay. So, during, I will give you the problem solving. You will apply this all appropriate formulas which is to be used or which are to be used. Okay? Ganon. Okay. Now, another thing is be careful with the units of pick you up with the units. Okay, usually units, and also will trick you out to the excessive data. Excessive data meaning so many data involved, but it is not used during the computation. This is the sample, so that's the two, right? Three style. The other style in the future examinations, it will give you a statement, a question that doesn't involve a given. No numbers, but you can compute by solving through standards values, something like that. Okay, for example, what is the velocity of planet Pluto? Like that. How can you compute? Diba? So, dito kamao. So, there's ang mga standards ni Ana. Okay? So, you can solve even though there's no given. So, more or less, there will be, assumption. But sometimes, wala siya assumption, guys. Okay, especially the Earth. It hit the asteroids in the universe. Okay, how to get the heat energy of impact? Nakakaloka. The heat energy of impact daw. Okay, meaning to say, the kinetic energy is not conserved. Only the momentum is not is in conservation again. Okay, so thank you so much. And then you can share this to your friends, to your neighbors, your sons and daughters. That this also will serve as a guide, okay, for little understanding for the subject matter, the specific topic, the potential energy, and its related topics. Okay, and I'm very, very grateful if you can also subscribe to the YT channel and then click the notification bell for some newest updates of I Am a Singer, Eternal Voice. Thank you so much. Bye bye. God bless everybody. See you later. Remember that Jesus loves us. Thank you so much.